Hello everyone. For today's chapter, we're going to talk about access control lists, also known as ACL. An ACL is basically a series of iOS commands that control the traffic of a network. On a Cisco router, you can configure a simple firewall that provides basic traffic filtering using ACL. Practically, ACL configuration can allow or deny packet sending by source address, destination address, protocol, or by port number. It can also provide traffic flow control by restricting the delivery of routing updates. So then, ACL provides more security and performance in the network. By default, a router doesn't have ACLs configured. However, when an ACL is applied to an interface, the router performs the additional task of evaluating all network packets when passing through the interface to determine if the packet can be forwarded. In addition, ACL can be used for selecting type of traffic to be analyzed, forwarded, or processed in other ways. ACLs can classify traffic to enable priority processing. Think of this like a VIP pass, where such pass can access first and has some privileges that normal passes do not have. ACLs enable administrators to control traffic input-output of a network. This control can be as simple as permitting or denying traffic by its network address, or as complex as controlling network traffic based on TCP port. Packet filtering occurs in layers 3 and 4 of the OSI model. This filtering can be done by source IP address, destination IP address, or protocol carried within the packet. Routers can filter packets based on source and destination port of TCP or UDP. ACLs define the set of rules for packets that enter inbound and outbound packets. ACLs do not act on packets that originate from itself. For inbound ACLs, the incoming packets are processed before they are routed outbound. It is efficient because it saves the overhead of routing lookups if packets are discarded. It is best to filter packets when the network attached to an inbound interface is the only resource of packets needed to be examined. For outbound ACLs, it is best used when the same filter will be applied to packets coming from multiple inbound interfaces. There's two types of IPv4 ACLs, standard and extended. Standard ACLs permit or deny traffic only from source IPv4 addresses, while extended ACLs base its filter on protocol type, source and destination IPv4 addresses, source and destination TCP UDP ports, or protocol type info for finer control. ACLs can have a name to identify them using numbers to determine the ACL type on the smallest network.
So, wildcard masking. Wildcard mask is a string of 32 binary bits digits used by routers to determine which bits of the address examine for a match. They look the same as subnet masks, but in an inverse mode. As we can see in the image, the zeros means that those bits will be ignored in that octet and then added to get the bitsum. Here are some wildcard examples. In the first one, we see that every bit must match exactly. In the second one, any host within that IP address and subnet mask will match. For the third example, the first two octets and the last in third octet must match. Some wildcard mask abbreviations. Host will permit a specified address, while any will permit any address. Guidelines for ACL creation. You can only have one ACL per protocol, per interface, and per direction. For the protocol, an ACL must be defined for each protocol. For direction, an ACL must be defined to control the inbound-outbound traffic, and for interface, an ACL must be defined for each interface. How do we place an ACL? For extended ACLs, we locate them as close as possible to the source of the traffic to be filtered. This way, undesirable traffic is denied close to the source network. For standard ACLs, it's usually placed near the destination, so it will protect the traffic from reaching any other network through the interface where ACL was applied. Placement of ACL depends on the extent of the network administrator's control, bandwidth of the networks involved, and ease of configuration. Let's talk about standard ACLs. To use numbered standard ACLs, you must first create the standard ACL and then activate the ACL on an interface. ACEs are processed sequentially, therefore the order in which ACEs are entered is very important. After a standard ACL is configured, it is linked to an interface using the IP access group command in configuration mode. This is useful to activate an ACL to an interface. Naming an ACL makes it easier to understand its functions. You can use remark keyword to include comments about entries. You can also edit by using the text editor or by using the sequence number. Once the ACL has been applied to an interface and some testing has occurred, the show access list command will show statistics for each statement that has been matched. In other words, this is a counter of the matches of each ACL. How do we use ACL to control VTY access? Cisco recommends using Secure Shell for admin connections to routers and switches. If the Cisco iOS software image does not support Shell, you can improve the security of admin lines by restricting VTY access. This is a technique that allows you to define which IP addresses are allowed. You can also control which admin workstation or network manages your router. Moving on to extended ACLs. For more precise traffic filtering control, extended IPv4 ACLs can be created. Remember that extended ACLs are numbered from 100 to 199 and 2000 to 2699. Extended ACLs can also be named. Remember that with extended ACLs, you can control source address, destination address, protocol, and port number. An application can be specified by configuring either the port number or the name of a well-known port. As shown in the image, there are some examples of applying a TCP or UDP specifications. Logical operations can be used, such as equal, not equal, greater than, or less than. To see a list of port numbers and keywords that can be used when building an ACL, you can use the question mark command like the image example. Configuring an extended IPv4 ACL. The steps for configuring extended ACLs are the same as for standard. The extended ACL is first configured and then activated on an interface. The established parameter allows only responses to traffic that originate from the 192.168.10.0/24 network to return to that same network. To apply an ACL to an interface, you have to declare the ACL, and then to apply it to an interface, you have to get into it and then type the IP access group command. Troubleshooting ACL. Inbound ACL logic. If the information in a packet header and an ACL statement match, the rest of the statement is skipped and the packet is allowed or denied as specified in the ACEs. This matching process continues until the end of the list is reached. At the end of every ACL, there is a statement which is an implicit deny any statement. This is not shown in output. The final implied statement applies to all packets which conditions did not test true and result in deny action. Outbound ACL logic. Before a packet is forwarded to an outbound interface, the router checks the routing table to see if the packet is routable. If not, it is dropped. Next, the router checks to see whether the outbound interface is not grouped to an ACL. The packet can be sent to the output buffer. IPv6 ACL. IPv6 is very similar in both operation and configuration. With IPv6, there is only one type of ACL, which is equivalent to IPv4 extended named. There are three main differences between IPv4 and IPv6. The first one is the command used to apply an IPv6 ACL, which is IPv6 traffic filter. The second difference is there are no wildcard masks. Instead, the prefix length is used to indicate how much of IPv6 address should match. The third difference is the additional default statement, such as the addition of two implicit deny any or deny any statements. So that's about it. I hope everything was clear and you guys understood everything. Thanks for watching.